Hello again and welcome to another episode of Aluminum Cutting Magic with the Proxxon milling machine. Micro milling machine. I'm making this for a friend from work. It's a component from the roller shutter on one of the windows in his apartment. It links the crank handle to the interior mechanism. Since this is an older model, it was impossible to find a replacement anywhere. Being made from plastic, my first thought was to mill it from a piece of Delrin. But if it's to have it fail after only 25 years like the first one, I really don't see the point. So I'm going to make it from aluminum. So as you can see, this is a step up in complexity from the sheet metal cutting you saw in the previous video. The part is more massive and will require milling to greater depths. The first complication is that the thickest block of aluminum that I own is thinner than the height of the piece. So I will have to compromise somewhere. On this face, this feature engages further into the mechanism, but I think it can survive without 1 mm. And on the other side, I will leave just enough for the hole and the locating pin. So, after taking some measurements, here is the part in fusion. I will have to do this in 2 setups, one for each side. So, manufacture workspace, then setup. When flipping the part on the second setup, I will need a reference point for alignment. What I'm planning on doing is making a through hole from side to side and use that as the reference point when flipping the part. So I'm using a slightly bigger stock than the piece and setting the origin here on the side. The end mill will be a 1/8 of an inch or 3.175 mm. The helix has to be at least the same diameter as the shank to be able to reach the depths needed for this project. Most of the parameters which I use I've shown to you in the previous video. The only difference here is that this time I'm mostly going to use pockets for the main features like the hole and the faces, and then a contour to part the object from the aluminum block. For the hole I'm doing half from each side to avoid milling to excessive depths. So, here is the aluminum block on the machine with the reference hole I mentioned earlier. Let's see how this goes. And disaster strikes. Double disaster. First the camera ran out of battery, and as soon as it was out, it broke an end mill. Rather typical for this type of machine. First it skips some steps and then it goes face first into the wall. It's amazing how these stepper motors will have enough power to break an end mill, but will lose steps randomly in the middle of the process. Or maybe I just haven't figured out everything yet? In any case, let's try again. Since the quality of my filming is a bit saddening, I'm not going to bother you with more images from the process. Anyways, here is the finished part. If you haven't figured it out yet, you can't make internal corners while milling from the top. Anyhow, this shouldn't be a problem for this particular part and the way it works. Are there any lessons to be learned from this small project? Well, for starters, I tried to carve the piece directly from the big block of aluminum. This meant a lot of plunging cuts, which are damaging to the end mills. In the future, I think I'm going to cut the stock to size and match it with the stock infusion. This way, the cut will start from the side and will be a bit more comfortable for the end mill. And then we come to the big one, skipped steps. I think you can kind of see where this is going and what the next project will be. Right, stay tuned and hope to see you soon. Bye bye.